Hello, everyone, and welcome to today's live webinar, Impact of Liquid Biopsy in Advanced HER2-Positive Breast Cancer Tumors, a Follow-Up Study. I'm Christy Jewell of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is brought to you by LabRoots and sponsored by Thermo Fisher Scientific. For more information on our sponsor, please click on the Thermo Fisher logo at the left side of your screen. Now let's get started. I would like to remind everyone that today's event is interactive, and we encourage you to participate by submitting as many questions as you want at any time you want during the presentation. To do so, simply type them into the Ask a Question box and click Send. We will answer as many of your questions as we have time for at the end of the presentation. If you have any trouble seeing or hearing the presentation, click on the Support tab found at the top right of your presentation window, or report your problem by using that Ask a Question box. This presentation is educational and thus offers continuing education credits. Please click on the Continuing Education Credits tab located at the top right of the presentation window and follow the process to obtain your credits. I would now like to introduce to you today's speaker, Dr. Matteo Allegretti, Postdoctoral Fellow. For a complete biography on our speaker, please visit the Biography tab at the top of your screen. Welcome, Dr. Allegretti. You may now begin your presentation.
Good morning, everyone. Thanks for the introduction, Christy. Before I start, I would like to thank Thermo Fisher to give me this opportunity to share our experience in the liquid biopsy field, particularly within metastatic breast cancer. These are my disclosures. Okay, let's start. For those of you who are not pretty familiar with breast cancer, I will briefly introduce this tumor and what are the main issues in the clinic related to the emergence of resistance. Then we will address the benefits of liquid biopsy that are rapidly transforming this technique in powerful non-invasive tool for mutation detection, tracking over time, and therapy assignment in different clinical settings. And finally, I will show you some unpublished data from a national multicentric study we are performing here in Italy, in which we investigated whether liquid biopsy may help in clinical monitoring of advanced breast cancer patients undergoing standard lines of therapy. As probably you know, breast cancer is one of the 5 big killers in the world, and it's generally recognized as the first leading cause of death for women. According to the last epidemiological estimates, more than 1.5 million of new cases are annually diagnosed in the world, with about 500,000 of women dying for the disease. With the groundbreaking work of Peru and colleagues at the beginning of this millennium, breast cancer started to be considered to consist at least of 4 main entities, 4 different subtypes bearing specific and clinically relevant features. I highlight in the red box the 4 histotypes, and from this cartoon you can easily see the main feature of each group. According to this classification, we can easily stratify patient outcome, demonstrating that molecular features have a direct impact on survival and prognosis. Therefore, huge efforts have been made to deeply understand the genetics of breast cancer, and to date, up to 10 different clusters have been characterized by using gene copy number and expression analysis, especially on tissue samples and cell line. Unfortunately, these evidences are not rapidly translatable into the clinic due to high cost and the need of specific requirements. And the main clinical focus still relying on mutational analysis for outcome prediction and therapy assignment. As I show you, among breast cancer, there is a specific group of patients that display HER2 overexpression. They generally account for 20% of total cases and are particularly of interest because they generally have aggressive disease and poor prognosis. Over the past decade, the management of HER2-positive breast cancer patients dramatically evolved because several targeted agents, including monoclonal antibodies, small molecule, and ADC, have been developed. And recent phase 3 studies, randomized phase 3 studies, have shown that the addition of this drug to chemo significantly improved PFS and overall survival, both in primary and metastatic settings. Here you can see what are the approved strategies for the HER2 subtype. Despite a good response to first line, generally the PFS and overall response rate drop down when we move to second, third, or later lines of treatment due to the emergence of resistant clones. This cartoon shows you the biological approaches that are targeted by the HER2 blockade. It has been shown that roughly all of this pathway may develop alteration during the natural history of the tumor, leading to resistance and ultimately to treatment failure. Okay, now why liquid biopsy? Of course, many of you already know the answer because the use of body fluids offers several advantages over conventional biopsy. This is a list of the main features of tissue biopsy as compared to liquid biopsy. I don't want to go in detail, but I'd like to underline that in a real world, generally we cannot repeat a tissue biopsy as probably needed, and in many cases, tissue samples are really insufficient or not available at all, representing the big issue to understand what is going on in the patient. Liquid biopsy may overcome many of these problems, offering a real comprehensive picture of the molecular landscape of the tumor, particularly if we are interested in spatial and temporal heterogeneity. This feature is progressively emerging as the most important thing to modulate therapy assignment over time, also in breast cancer. For this reason, liquid biopsy is being progressively applied into the clinic, both in advanced and early settings, as you can see from this representative timeline. As part of a molecular lab, one of the most important things before starting sample profiling is to select the optimal technique to answer a specific question. But as you know, tumors are dynamic entities, and during their natural history, they evolve. Therefore, it's also necessary to maintain such a high flexibility in the workflow we use. We can face, for example, with different questions like why metastases emerge or why a specific patient responds and eventually relapse after a year. Each of the great steps that I highlighted here in the slide can be easily tackled by using the right technology. Basically, in every setting, we should prefer high sensitivity techniques like multiplex digital PCR to address low frequencies, while on the onset of the tumor, we can be interested in understanding the key feature of the cancer altogether, and we should prefer high throughput platform like NGS. During therapy, multiple samples may be also available, so we need to adopt a strategy that minimizes costs and maximize the output. And finally, we may address tumor heterogeneity by using again NGS to better understand what could be the best strategy for this patient. Today, different solutions are available on the market. For liquid biopsy, they essentially rely on NGS, both targeted or amplicon-based, and digital PCR. Both workflows started with nucleic acid extraction and are made of really simple, rapid, and straightforward steps, from sample preparation to data reporting. Here you can see some examples of the steps that are needed to achieve a result with this technique. Now, I would like to share with you our experience on breast cancer. We investigated the clinical feasibility of liquid biopsy in the HER2 positive subgroup by establishing this multicentric study here in Italy that involved several cancer institutes across the country. by collaborating with IRC, the Italian Association of Cancer Research, and GIM, the Italian Group for Breast Cancer. In this project, we firstly assessed tissue samples to list index mutation, and then we sequentially analyzed by a combined NGS digital PCR approach a collection of serial blood samples we obtained during the clinical follow-up of the patient in order to quantify the impact that liquid biopsy could have if applied in a real clinical setting. Today, we enrolled 31 cases, 20 of which were fully characterized at this time with respect to molecular features. Tissue samples were available for almost all of the cases, so we were able to obtain a fine characterization of the initial tumor profile. More than 300 blood samples were collected during the follow-up of the patient, with a mean of 15 blood samples per case. Regarding the technical aspect in the blood, we ran about 100 pan cancer assays, and in this blue box, I show you an overview of the data we obtained. I would like to focus your attention on two main points. The first, the percentage of cases that liquid biopsy score as positive at baseline and at relapse, that was around 65-75%. And the second, the performance of the assay in terms of median limit of detection we obtained by using as input just about 20 nanograms of circulating total nucleic acid. But most importantly for us was the concordance with clinical outcome as defined by RECIST criteria. As you can see in the box below, 80% of our liquid biopsy data correlated with the clinical response obtained by the patient, and I will show you some example of that in the next few slides. As to digital PCR, the vast majority of the work was performed to design and validate custom assays because the majority of the SNP we found in the tissue were not so common. Here, the percentage of the positive case was a little bit higher as compared to NGS, but this was expected. Also, by using lower amount of DNA as input, the concordance with clinical and NGS data remained very high, as you can see in the box in the last part of the blue table. We notice only a drop when we explore very low variant allele frequency, but this is largely expected due to the difference in sensitivity by the two platforms. Okay, now I will show you some representative examples from our collection. The first case I would like to introduce comes from a woman with a very aggressive disease. She underwent surgery in 2017 and she was diagnosed with a so-called triple positive metastatic breast cancer. She started immediately as first line a dual blockade and two antibodies, but unfortunately she relapsed before the year. Then she moved to TDM1, but again the progression was very fast. During this period, we have the possibility to serially sample blood and to have access to the tissue biopsy of the primitive tumor. The NGS analysis shows the presence of one of the most common PI3K mutations at a very high frequency in the tissue. The same mutation was found by NGS and digital PCR at baseline in the blood, and this was how it looks in digital PCR. Then we analyzed sequential blood samples collected during the clinical follow-up of the patient, recording this trend over time. A huge escalation, as you can see by the graph, of the variant allele frequency was found until clinical relapse. As you can see by the red bar, NGS and digital PCR, when combined in the same time, showed the same value in the same blood sample. But what was very important for us was that liquid biopsy, if we were able to test blood at the time of sampling, may anticipate the failure of the ongoing treatment at least 2 months earlier than CT scan. Then the patient went on starting a third-line therapy. We were able to sample her blood in multiple occasions. For example, after 3 months, NGS and digital PCR documented a clear reduction of the PI3K mutation, while the PET scan showed only stable disease. We repeated the analysis 2 times more, and after additional 3 months, the PET scan finally showed a partial response. Again, liquid biopsy, if applied prospectively, would have been able to predict the outcome about 5 months earlier than conventional clinical imaging. The patient continued her treatment, and 3 months later, we found an increase in terms of copies per ml of the PI3K mutation in the blood, but still in the presence of stable disease as shown by PET. 8 months later, a huge increase of VAF was noted by digital PCR and NGS. Unfortunately, at this time, we were unable to collect a clinical report of the situation, so we probably foresee a novel relapse in the patient, but we cannot confirm that. Another example I would like to share in terms of primary resistance comes from this 56-year-old woman who was initially diagnosed as HER2 negative. She failed the first line very quickly, becoming HER2 positive, and she started a dual blockade as a second line, but failing again, and she came to our attention just after the third line therapy that unfortunately she failed very fast once more. Tissue samples were not available for this patient, but liquid biopsy on blood was able to show the presence of one TP53 mutation. This mutation progressively arises over time, demonstrating to be probably the resistant mechanisms of the disease to the treatment. Again, as you can see by this graph, liquid biopsy would have been able to predict relapse earlier than conventional imaging. Okay, now I will show you some representative cases from our collection. The first case I would like to introduce comes from a woman with a very aggressive disease. She underwent surgery in 2017 and she was diagnosed with a so-called triple-positive metastatic breast cancer. She started immediately as first line a dual HER2 blockade, but unfortunately she relapsed over the year. Then she moved to TDM1, but again the progression was very fast. During this period, we have the possibility to serially sample blood and to have access to tissue biopsy of the primitive tumor. The NGS analysis showed the presence of one of the most common PI3K mutations at very high frequency in the tissue. The same mutation was found by NGS and digital PCR in the blood at baseline at very similar VAF. This was how it looks in digital PCR. Then we analyzed sequential blood samples collected during clinical follow-up of the patient, recording this trend over time. A huge escalation, as you can see by the graph, of the variant allele frequency was found until clinical relapse. As I indicated by the red bar, NGS and digital PCR, when combined, show more or less the same value in terms of VAF. But what was very important for us was that liquid biopsy, if we were able to test blood at the time of sampling, may anticipate the clinical failure of the ongoing treatment 2 months earlier than CT scan. Then the patient went on starting a third-line therapy. We were able to sample her blood in multiple occasions. For example, after 3 months, NGS and digital PCR documented a clear reduction of the PI3K mutation, while the PET scan showed only stable disease. We repeated the analysis 2 times more, and after additional 3 months, the PET scan showed the partial response. Again, liquid biopsy, if applied prospectively, would have been able to predict the outcome of this patient about 5 months earlier than clinical imaging. Then the patient continued her treatment, and 3 months later, we found an increase in terms of copies per ml of the PI3K mutation in the blood, but in the presence of a stable disease. 8 months later, as you can see by this last image, a huge increase of VAF was noted by digital PCR and NGS. Unfortunately, no clinical reports were available at this time, but probably we foresee a novel relapse. Another example I would like to share in terms of primary resistance comes from a 56-year-old woman who was initially diagnosed as HER2 negative. She failed the first line very quickly, becoming HER2 positive, and she started a dual blockade as second-line therapy, but failing again. She came to our attention after the third-line therapy that unfortunately she failed very fast once more. Tissue samples were not available in this case, but liquid biopsy on blood was able to detect the presence of one TP53 mutation. This mutation progressively arises over time, demonstrating to be the resistant mechanism to this treatment. Again, liquid biopsy would then be able to predict relapse earlier than conventional imaging. One of the key advantages of liquid biopsy over tissue is the possibility to take a picture of a precise moment. In this case, we were able to analyze multiple lesions from the patient, showing clearly the presence and selection over time of a PI3K mutation, as you can see by this table. In the left part of the slide, I put some clinical information of this case, but what I like to stress is that primitive and liver metastases were collected years before the starting of the last line of therapy, when the patient comes to our attention to run the liquid biopsy analysis. And we could hypothesize that something happened in the meantime in terms of molecular changes. Indeed, when we performed liquid biopsy, we were able to document the complete absence of the PI3K mutation we found in tissue at baseline, and also in the first 2, 3, 5, up to the 5th blood draw we collected from this patient. The patient unfortunately progressed about 1 year later the starting of therapy, and as you can see by the strand in the blood, both NGS and digital PCR could detect a progressive increase over time of the PI3K mutation, with a leading time of 2.8 months as compared to clinical imaging. In many cases, as in this, liquid biopsy may help to identify a rising mutation. Here, we haven't access to tissue samples since needle biopsy found in the patient were previously used for immunohistochemistry and were not available. Besides the fact that liquid biopsy couldn't detect any baseline mutation, we were able to identify an actionable ASR1 SMB right before the progression of the patient. More in general, if we consider only the relapsing cases, liquid biopsy was able to identify at least one aberration in the blood in all sorts of samples, with on average a lead time to relapse of 3 months. Generally speaking, the most important advantage of a liquid biopsy approach is to properly define tumor heterogeneity. These women had an HER2 negative disease that rapidly evolved as HER2 positive in multiple sites. As you can see, she faced very quickly several lines of therapy before coming to our attention. We firstly analyzed her tissue by NGS, showing the presence of a p53 mutation that further disappeared in the skin metastasis. In the blood at baseline, digital PCR and NGS was able to detect some mutation on ESR1. Especially digital PCR identified two mutations that were previously absent in the tissue, one of which was not detected by the NGS because at very low frequency. At relapse, the patient developed a new SR1 mutation, the Y527M, and the clone that was originally present at the lowest frequency became the most prevalent. This was the trend over time. The patient started then a first line of therapy with fulvestrant and capecitabine, and 3 months later, CT scan showed a partial response with 60% of reduction of liver metastases and no pleural effusion. We analyzed the corresponding blood samples showing a clear reduction of the ESR1 mutation with the complete disappearance of the Y537S, the most prominent clone found at relapse to the third-line therapy. As showed before, liquid biopsy may identify in a very simple and fast way an eventual response to treatment. Here, there are 3 cases in which we were able to identify clear response yet after the first 2-3 time points, earlier than the first clinical evaluation. I would like to focus your attention just to case number 19. At baseline, the NGS panel we applied was able to detect only the HER2 mutation, but by using the index we previously identified in the corresponding primary tissue, we were able to design a specific assay for the PI3K mutation found in tissue, and we were able to identify its presence in the first time point. This was just an example to remind you that tissue profiling is still important, even in the growing landscape of liquid biopsy. Of course, even in the case of liquid biopsies, we can face with several issues. As you can see by this spaghetti plot, in our study, the vast majority of mutational trajectories strongly correlate with the clinical outcome of the patient. However, in some cases like these, liquid biopsy scored as approximately negative. Some patients that really develop progression disease. In these 2 specific cases, progression disease was due for brain metastasis. This was not surprising because there are plenty of studies in literature demonstrating the inability of blood-based analysis to properly recapitulate the molecular feature of brain tumors or brain metastases. But in this case, however, a liquid analysis of CSF may better define tumor features. Moreover, in other cases like these 2, it happened that liquid biopsy results were not really informative. For example, in the case of sample number 6, we documented a strong reduction of the PI3K in the blood in spite of progressive disease. This was initially counterintuitive, but when we take the biopsy from this patient from a skin metastasis, it was confirmed also in this tissue, thus suggesting that other mechanisms were sustaining the progression we are seeing. Another great improvement of liquid biopsy to cancer profiling is the possibility to track the evolution of the tumor, suggesting additional lines of therapy. As you can see here, the majority of our samples showed at least one aberration at baseline, and some of them acquired additional mutation and relapse. Only in a minority of cases, as those I presented before, Progression disease for brain metastasis impair the ability of liquid biopsy to identify tumor aberration in the blood. Besides the strong correlation we found between clinical and plasma behavior that I represent in the middle of this table, I would like to focus your attention on the right part of the table regarding the actionability. According to the latest OncoKB criteria, in more than 60% of our cases, the application of liquid biopsy into the clinic would result in additional therapeutic strategy for the oncologist. In one-third of these cases specifically, these mutations were not seen in the corresponding tissue, probably due to the sampling time that occurred year before the initiation of the treatment. In other words, these results strongly suggest that liquid biopsy may complement tissue analysis in the routine investigation undergoing for cancer profiling. This is my last slide with some common and take-home messages. I showed you that liquid biopsy may allow the identification and monitoring over time of persisting or de novo acquired mutation, most of which could be linked to the response or resistance to a specific treatment. By doing that, liquid biopsy, particularly in breast cancer, strongly correlate with the clinical outcome, giving the possibility to predict in a very accurate and fine way treatment response earlier than conventional imaging. In some cases, an NGS-based approach offers also the possibility to track, taking into account really a spatial and temporal heterogeneity. As I showed before, it's still important to keep in mind that tissue profiling may help even when we are speaking about liquid biopsy, and that it's absolutely recommended, in my opinion, to proceed with a combined approach, particularly by using NGS and digital PCR to avoid misinterpretation of the results due to the limit of detection of each technique we use. With this, I conclude my talk, and I'm happy to take questions for you. Thank you.
Thank you, Dr. Allegretti, for your informative presentation. We will now start our live Q&A portion of the webinar. Now, to our audience, if you have a question you would like to ask, please do so now. Just click on that Ask a Question box located on the far left of your screen, and we will answer as many questions as we have time for. Okay, let's get started. We have several questions already coming in. Dr. Allegretti, what are the advantages of in-house testing versus outsourcing to a service provider?
Oh, there are several advantages. In my institute, since we are a research clinical mixed institute, we just go upstairs, take the sample, and proceed quickly to plasma isolation and analysis. But in this project I showed you, we use a multi-center approach. So in this case, we prefer to isolate to process sample directly on site without going for an outsourcing, So just having the possibility to train the internal personnel to store properly, to process and store properly sample and then ship after. In general, in my opinion, it's preferable to apply an internal approach. So in other words, using all the methodology like NGS or other high throughput platform or high sensitivity machine like digital PCR in-house without sending out from the institute the sample, because in some cases also the management, the shipping of the sample may alter what are the features of the sample. Yes, there are a lot of solutions that stabilize blood samples, like tubes that contain preservative, but it may happen something that the sample, for example, is not shipped properly, or it comes to the final central laboratory that is in charge of the analysis later than what was originally planned. So in this case, it's equal to lose the sample. In general, we prefer to process and to use an internal approach to manage all this kind of liquid biopsy project, all this kind of liquid biopsy related issues.
Thank you, Dr. Allegretti. Now our next question has two parts. How much cell-free DNA or cell-free TNA did you use when you analyzed tissue and plasma with NGS and dPCR analysis? And what about blood? How many tubes were needed to get this amount of material?
Okay. As to the first question, it depends on the sample. For tissue analysis, we generally base our NGS using 10 nanograms of DNA as input, but specifically speaking in this project, we face also some cases with less material, and we properly obtain data also from an NGS starting from 5 or 3, if I remember, probably 3.5 nanogram was the lowest amount we use for tissue analysis. As to plasma, it depends also on the timing of the sample, but in general, we were able to obtain at least 20 nanograms of circulating total nucleic acid as input, and we use this amount as input for our NGS analysis. In some cases, we were able also to perform the same analysis with up to 40 nanograms of material, total material, but it happens only rarely. If I can go back on my slide, in the slide in which, yes, maybe it's this one, if yes, I put a range of the input we use for here there is mean or input we use for blood NGS analysis in the blood 4 to 40 nanograms, and the median input was 22. Yes, these are the mean we obtain on average also with other cancer types like colon or lung cancer cases we generally process with the same approach in our institute. And the second question, Christy, could you repeat me the second part of the question?
Absolutely. What about blood? How many tubes were needed to get this amount of material?
Okay, it's depending on the protocol. In this specific project, we were able to draw from the patient up to 20 ml of entire blood. But in other projects we are running in the institute, our ethical committee give us the authorization to process up to 30 ml. In general, we were, as a general opinion, we can process, we can obtain data starting from one 10 ml tube of entire blood, because it's equal of 4-5 ml of plasma, and we can easily obtain the minimum amount in terms of total nucleic acid, total circulating nucleic acid we need to run an NGS panel, a targeted NGS panel.
Thank you. Are there any differences in terms of ctDNA yields among research sample in different types of cancer?
Oh, yes, particularly when we are speaking about other types of cancer like colon or lung cancer. In our experience, we generally, in my institute, we are in charge of processing different types of liquid biopsy sample. starting from breast to thyroid cancer, colon, lung, and so on. And we see this kind of difference, for example, colon cancer, where generally contain generally higher number of amounts as compared to breast, as compared to other race cancer like medullary thyroid cancer. And yes, the answer is yes. Properly, there are some kind of tumor like gastrointestinal tumor or in the lung, in some cases stage 4 lung cancer that display huge amount of cell-free DNA in the bloodstream. So the analysis from this kind of sample can be defined easily than the same analysis with the same approach from other kind of samples.
Thank you, Dr. Allegretti. We have time for a few more questions. What is the criteria or the rationale that you followed to decide that after a series of dPCR tests, it was necessary to perform a new NGS test?
Okay, it depends. In this specific project I show you, we adopt a fixed timeline of NGS analysis. We run NGS as baseline, at relapse, and in every occasion the patient underwent clinical imaging to have an idea of what's going on in the patient. In other projects, we generally perform an NGS analysis at the baseline just to have an idea of what can be the difference between the tissue whenever it's available. So the NGS analysis performed on tissue and the first time point of blood, because in general this patient comes to our attention after several lines of therapy, and on average the median time of sampling of tissues is year and year before the first time point, so the first blood analysis we perform in the patient. So what's the right timeline? I cannot give you a precise answer, but it depends on, firstly, on the kind of tumor. There are some tumors that evolve very quickly. So in this case, like pancreas, we generally perform NGS after 1 or 2 blood samples and repeat the same analysis with NGS before the first months of clinical follow-up. In other cancer, like as I said before, thyroid cancer, that are generally characterized by an indolent progression, we perform NGS one time every 6 months. So in this case, the schedule is a little bit spread over time. It depends, firstly, on the type of tumor, and secondly, also it depends on the condition of the patient. Within our institution, Molecular Tumor Board, we were able to face with different patients in different situations. Generally, metastatic patients need to be analyzed by NGS more frequently than patients that are subjected, for example, at surgery, so patients that are at earlier stage of the disease. In the latter, we generally prefer to do an NGS analysis on tissue and an NGS analysis at baseline, and then analyze in terms of molecular behavior the blood sample we collect after surgery, for example, just by digital PCR to monitor specifically, for example, KRAS mutation in the colon cancer setting or the EGFR mutation in the lung cancer setting. So the right answer could be it depends on the type of tumor and the condition of the patient. Cannot provide you a precise timeline outside my experience.
Thank you, Dr. Allegretti. And in the take-home messages, you say that data from LV-based approaches must rely on both tissue and blood samples. Would you please explain a little bit more why you see liquid biopsy as a complementary technique to tissue biopsy?
Yes, I showed you in some of the previous slides an example of this. In general, NGS panel, especially the targeted panel, cover a list of sufficient targets. For example, 40 gene, there are 40 gene panels that span over all the actionable genes. But in some cases, the amplicon that are inside in this kind of panel may not target the real mutation that are present in tissue. And case number 19 I showed you before, it was a perfect example of that. So in this case, tissue analysis, tissue profiling may complement liquid biopsy, but in general, liquid biopsy, according to what I said before about the timing of sample of tissue, generally complement tissue analysis because what we can derive from tissue may be different, may be submitted to some changing over time, for example, during treatment, and it reflects only a past situation. For example, what we can derive from the primary tumor, it's always before, it's always not modified by the ongoing treatment after the primary resection of the tumor. So in these cases, liquid biopsy may complement tissue analysis because it offers a precise picture of this precise moment and not a past overview. In general, liquid biopsy may also give may complement tissue analysis because it gives a general overview of the evolution of the tumor. So it could be easier for example, an oncologist to assign further lines of therapy based on an evaluation of the precise moment, of this precise moment, as compared to give additional lines of therapy as the original tumor profile because it was influenced over time by the ongoing treatment.
Thank you again, Dr. Allegretti, for this insightful Q&A session. Now, before we go, I would like to thank our audience for joining us and for their interesting questions. We had quite a few questions come in that we were unable to answer. So those we did not answer live today and those submitted during our on-demand period will be addressed via the contact information you provided at the time of registration. I would like to once again thank Dr. Matteo Allegretti for his time today and his important research. I would also like to thank LabRoots and our sponsor, Thermo Fisher Scientific, for underwriting today's educational webcast. This webcast can be viewed on demand, and LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. That's all for now, and we hope to see you again soon. Have a great day.